Hello and welcome to Mr. Linford's math course. In today's presentation, we're going to be talking about more of a statistics related topic, and that is the measures of center and the measures of spread for a given data set. In particular, we're going to talk about the three values to measure what's called the central tendency of the data set, the mean, median, and the mode. And then we're going to talk about a way of measuring the spread of the values in a data set as related to the mean, and that's the standard deviation. First, let's go ahead and let's talk about the measures of center or the measures of central tendency. Imagine that you have a data set. We oftentimes talk about, well, what's in a data set? What's a typical value that we're finding here? What's the average value? The word average is used quite a bit. And it's to describe what a typical value is, what a central value is, or middle value, or something that best describes the data. Okay, the value that best represents the data set. Now, when we say average, there are three different ways of describing the central value, a typical value in the data set. One of the ways is by the mean, or the arithmetic mean. The mean is where you take the sum of the data values. So you add up all the terms and then you divide by the number of data points. So that's where you are, and this is what people most refer to when they talk about an average. This is a process for adding up all the values you have in the data set and dividing by how many there are. This is what's called the arithmetic mean, and it's typically what people refer to when they mean the average. However, another common term that's used for describing the average of a data set is the median. Now, the median is different than the mean. The median is if you were given a data set, the middle value that's representative in the data set when you order it from least to greatest is the median average. The median is the middle value of a data set when you arrange it from least to greatest. Now, another term for average, and used another way of measuring the central tendency, is the mode. The mode is when you take a data set, the most common number. It's the number that occurs most often in the data set. Okay, let's take an example here, a simple example of a collection of numbers. Here's a data set, 4, 1, 6, 1, 8, 7, 4, 4, 2, 3, and 4. Let's take this data set and let's identify the mean, the median, and the mode. One thing that's helpful anytime you're working with a data set, no matter what, if you're trying to find the mean, median, or the mode, it's helpful to rearrange the numbers in ascending order from least to greatest. So let's go through and let's rewrite this data set. So I have, let's see, a 1 up front, followed by another 1. Let's see what comes next. There's a 2. Any other 2s? Nope, but I see a 3. I don't see any other 3s, but I see a couple 4s. There's a 4 here. Then there's another 4 there. There's a third one right there, and then another 4 right there. There are no 5s, but there is a 6, and then a 7, and then an 8. So here is the data set arranged from smallest to greatest value. Let's go ahead and let's find the arithmetic mean, the median, and the mode. To find the mean, we have to add up all the numbers in this data set, and then we have to divide by how many there are. So let's add these up. Let me change colors here. I'll do the mean in green. So we have a 1 plus 1 plus 2 plus 3 plus 4 plus another 4 plus another 4 and one more. And then we have to add in a 6, a 7, and an 8. So we're supposed to add all of the data values, then we divide by how many there are. So here, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. there are 11 data values here. So we're going to divide all of these, when we add them up, by the number 11. When I add all of the values on the top together, I get a 44, and that divided by 11 is 4. So the mean value is the number 4. This is what we typically would consider the average. But we can also find the median number if we're talking about the average. Now, the median number is the middle value of this data set. Keep in mind, it's not the middle value of the original data set, right? This is just in any random particular order. It's when they're arranged from highest to lowest, what's the middle number? Well, let's see. Not 1 and not 8, not 1 and not 7, not 2 and not 6, not 3 and not 4, not that 4 and not that 4, but that one right there. That 4 is the middle number. You'll notice that in this data set, I do include numbers multiple times, right? There were 2 1s in here. There are 4 4s. You want to include those, and you list them out as many times as necessary. Because look at this data set. There are a lot of 4s in there. So that probably has a bearing on, or at least influences what the median value is. So it happens to be that 4 is the middle number. There are 1, 2, 3, 4, 5 numbers on this side, 1, 2, 3, 4, 5 numbers on this side, and that one's right in the middle. So we'll say the median is 4. Now the mode, again, the mode is the most common number that occurs in the data set. So in this case, yeah, there are 2 1s, but it looks like there are 4 of these 4s. So we're going to say again that 4 is the mode. It is the most common number. Okay, in this example, you see that the mean, the median, and the mode are all the same number. That doesn't always happen. No. That's not necessarily something that happens very frequently at all. It just is because of how I picked this data set, okay? I just wanted a simple data set for us to work off of. Don't assume the mean, the median, and the mode have to be the same numbers. In fact, in most cases, they're all different numbers. And sometimes there doesn't even have to be a mode to a data set. For example, if you had the data set 1, 2, 4, 7, 9, you can find the mean of this, you could find the median, but there's no mode. There's no value that occurs more times than any other value. So the mode is one of those situations where it can be useful, but it's not going to occur as frequently as the median or the mean. So this is an example of how we find the mean, the median, and the mode for a data set. Let's try this example on our own now. Here I've given you the data set of 2, 3, 5, 12, 3, 18, and 8. What I'd like you to do is take this data set and find the mean, the median, and the mode for the data set if they exist. And if so, write them out and identify what they are. Pause the video, give this a try on your own, see if you're comfortable with how to use the formulas and how to identify what each of these values are, and then we'll check back in just a minute. All right, well, hopefully you had some time to work through this. You'll notice that before I started working through any of the work, I actually rewrote the set in ascending order. I started by the smallest value and went to the highest value, and I didn't delete repeating values. You'll see that I definitely made sure to include if there were multiple of the same value. We will need that when it comes to finding the mean and the median and the mode. So when I started finding the mean, I took all of those values, I added them up, and I got 51. I then divided 51 by how many data points there were. Well, I counted 7, so I took the 51 divided by 7, and I had 7 2/7. I think that's 7.2 something. But that is the mean. That is the arithmetic mean average. Now, if we were talking about the median average, that's the middle number in the data set, including having multiple values listed. So I listed all the values again, 2, 3, 3, 5, 8, 12, and 18, and I got to the middle value of 5. That is the median average. That's the middle value that we have. Now the mode, it was actually should have been fairly obvious. When you have all these out, you can see that 3 is the only number that occurs multiple times. So 3 was the mode. It was the most common occurring value. Let's try another example, little different setup. Take a look at this example, and I want you to find the mean, the median, and the mode. Again, I think it would be helpful to rearrange these terms in ascending order before you begin, and then go through the process. As you work through finding the mean, the median, and the mode, think about what their definitions are saying. Think about what the goal is for each one. What the mean is, what the goal of the median is, and what the goal of the mode is when deciding these values. Take a minute, pause the video, and let's see what you come up with. All right, well, hopefully you had some time to work through this problem, and hopefully you noticed where this problem was a little different than some of the problems we previously worked on. First off, when we go and calculate the mean, things should have been pretty standard. All we did was added up all of the terms. You'll notice I rewrote them in ascending order. That's just me. But I added the 1, the 2, the 6, the 3 7s, and the 9, and I got 40. Now I divided it by how many data points there were. Since there were 8 values, I divided the 40 by 8 to get 5. So 5 is the arithmetic mean, or the mean average of the data set. Now, the median was a bit trickier. The median was a little different for this problem. You'll notice that when I laid out all of the numbers, again in ascending order, and I tried to find what the middle number was, there was a problem here. The problem is there's an even number of data points. Well, there really isn't a middle number, is there? Because you have 2 numbers, there's 4 on one side, 4 on the other side, so there's not a number necessarily right in the middle. So what we do when we have a median of, when we need to find the median of an even number of data points, you take what's in between the 2 middle numbers. So the 2 middle numbers here are 6 and 7, so take the value that's in between them. 6.5 would be the median in this case. It's okay that 6.5 was not in the data set. That's fine. That's totally okay. Again, we only do this when there is an even number of data points. Okay, when there's an even number of data points, we have to say, okay, take the 2 middle numbers and find what's right in between them. Now, this was pretty easy, but let's say the middle numbers were something like 30 and 58, right? Let's say you had an even number here and an even number here, and these were the 2 middle numbers. How would you find what's right in between? Well, there is something called the midpoint formula. You can easily find the number in between 2 numbers, and I'll give you that formula really quick. Basically what it is you add these 2 numbers up and then divide them in half. So if you're trying to find what's in between 30 and 58, you would take 30 plus 58 and divide it by 2. So 30 plus 58 is 88. Let's divide that by 2. It's 44. Okay? So you would say for this given data set, again, we're pretending that there's some even number on both sides, and these are the 2 middle numbers. 44 would be in between them. So that's a way of finding what's in between 2 numbers. You add them up and then just divide by 2. Now for the mode, again, this was fairly easy. You can go through and see, oh, well, there's 2 1s, but wait a minute. There's 3 7s, and nothing else repeats 3 times. So 7 is the most occurring number here. What I want you to notice is all of these numbers, the 5, the 6.5, and the 7, are somewhat fairly close in this data set, right? Maybe the 5 and the 6.5 probably are a little more representative of what we're seeing here. Maybe 7's a little on the high end. But you will see that the mean and the median are pretty good indicators of what the central value is, of what the typical values we're seeing in this data set. So again, in the event that you need to find the mean, It's pretty much always this process. If you need to find the median, it's the middle number, or it's the number in between the two middle numbers if you have an even number of data sets. And the mode is just the most occurring number you have. And again, the mode doesn't have to exist. There doesn't have to be a mode for a data set. Now that we've talked about the measures of center and how we can find the average or typical value or the central value of a data set, let's also talk about the spread of the data. It's important to know how the data is dispersed. Is your data very tightly packed together, or is it spread out over an area of over different values? In particular, when we talk about the spread of the data, we want to talk about the standard deviation. A standard deviation is a measure. It's a value that measures how dispersed or how spread out a set of data values is from the mean. Once you know what the mean to the data set is, what that average value is, the standard deviation really measures how far away or how far spread out is most of the data. Is it very tightly packed together around the mean, so they're all very close in value? Or is the data set really kind of dispersed and spread out across different values? So when we talk about the spread of data, we might talk about a low standard deviation or a high standard deviation. For a low standard deviation, we would have most values in the data set fairly close to the mean. A low standard deviation means you're not that far away from the mean, okay? The majority of your data, I will say, is not that far away from the mean. And when I say majority of your data, I mean over half of the data points, okay? I mean over half of your data is fairly close to the mean. Now for a high standard deviation, that means that there is more spread for the data. Okay? Most values are spread out from the mean. Okay? Now, when I say most, I mean over half, over 50% of the data. Now, there are very technical formulas to finding standard deviation. How do you find a standard deviation? How much is enough? Like when you say most, over 50%, is it 51%? Is it 52%? Is it 60% or 68% of the data? There are certain requirements in place for standard deviations, how we calculate standard deviations, how much we describe is within a standard deviation from the mean. We're not going to get into all of that today, okay? That's something for a much later discussion. It's a bit more formula heavy and a bit more complicated to get through. We don't need to talk about that right now. We just need to understand that a standard deviation is just a measure of how far away from the mean is most of the data, okay? Is most of the data, over half of the data really far away? Or can you go very close to the mean, only a little bit away, and you'll have most of the data? Let's take a look at an example and see if this makes a bit more sense. So let's pretend you're measuring the heights of dogs. So you take a sample of dogs and you measure their heights to be 600 millimeters, I almost said milliliters, 600 millimeters, 470 millimeters, 170 millimeters, 430 millimeters, and 300 millimeters. Okay, what is the mean of this? Well, if you add up all of these numbers, the 600, the 470, the 170, the 430, and the 300, and you divide by how many there are, let's see, there are 5, you should get 394 millimeters. That's the average height of the dogs, okay? Let's go ahead and I'm going to first rearrange this, this data set so we have it in ascending order. So let's see, the highest value we have is 600. I'm going to say that's right here. And I'm going to say 0 is right here. So that means right in the middle should be 300. So let's say in between that is 450. In between here is 150. So let me mark this in different colors here. Here's the 600. Let's say 470 is, let's say right here, 470. Let's say 430 is about right here. And let's see, 170, let's say that's about right here, 170. And we have 300 right here, and 600 right there. I think we're set. So here are the data points, and we get the mean to be 390. Well, let's see, 400, and let's say right about here is the mean. 394, okay? Again, we're eyeballing this. So 394, there's the mean. The standard deviation of this sample of dog heights. Again, there is a specific formula for this, okay? We're not going to get into all of that. The standard deviation, and I'm rounding this value, is 165 millimeters, okay? That's the standard deviation for the sample of dog heights. So if we have a standard deviation of 165, that means 165 units away from the mean of 394 would take us to about 559 or 560, so somewhere right about here. Let's say 559. And then we would also be below this a certain value. So let's see, 394 minus 165 is 229. So it's about 230. Let's say that's somewhere right about here. 229. So this range, everything in this range, this is where we're going to say a majority of our data lives, okay? Over 50% of our data is within the range of 229 to 559, okay? This is one standard deviation above and one standard deviation below the mean, okay? We're saying in this range, above and below the mean, this is where most of our data will live, okay? Let's take a look at an example where we're going to try to compare standard deviations to see how low they can be and how widespread they can be. Here's an example where two classes of 25 students each took an identical exam. Their percent correct scores are shown in the dot plots here. Now, a dot plot, I should mention this pretty quickly. A dot plot is just a type of a graph. We'll talk more about this in another video, but basically all that means is here are a list of scores that students received. Every time a student got, let's say, an 83, the teacher put a dot above 83. So when the first student got 83, we put a dot right there. Then another student got 83, we put a dot above that. And then another student, we put a dot there. Let's say a student got an 86, we put a dot here. Then, we find another student later gets an 86. We'll put a dot there. And again, every time a student gets that particular score. So this is a way of arranging the scores. These values right here on the y-axis, these are the occurrences. These tell you how many students got this particular score. So as opposed to writing out the data set of, well, there was an 80, there were two 81s, there were three 83s, and another 83. And then there were four 84s. Oh my gosh, this is taking a while, isn't it? Instead of just listing things out, what the dot plot does is it gives us a nice visual representation of what's going on here. We can see that 5 students got 85s, 1 student got a 90, 2 got an 89, 2 got an 81, 1 got an 80, 3 got 83, and 3 got 87. And it looks like 4 got 84 and 4 got 86. We see a general, breakdown of what's going on here. This is for one class. We also have a second class, Class B, where again we're seeing, okay, 3 students got 80, 3 students got 83, 2 got an 84, 3 got a 90, 2 got an 88, etc. That's what a dot plot means. All it does is it is a nice visual way of counting how many occurrences there were for these different grades, how many students received these different grades. So, what are some things we notice about these? Well, it looks like in Class B, more students got a higher grade of a 90 than students in Class A. But you'll also see more students got the lowest grade as opposed to Class A. So, what we want to talk about here, of these 25 students, we want to interpret the standard deviation, okay? What can we say about the standard deviation for each of these data sets? We want to describe how tightly packed is this data? How close is a majority of the data? Or is the majority of the data really spread out? Do we have to go rather far to encompass a majority of the data? Take a minute, look at the graph first, and see what you think, what initial reactions you have about the standard deviation for Class A and for Class B. Now, as you look at the distribution of scores here, I want you to notice that 85 pretty much is the mean for both of these. I think it's actually a little higher in Class B. I think it's like 85.4 or something. But roughly, that's the mean in both of these. How far out do you have to go to encompass most of the data? Well, take a look at Class A here. If I went out 2 values above and below, let's say that this is 1 standard deviation. Let's just say that, okay? It's 2 values above and 2 values below. And let's say I did the same for the other graph. And let's pretend this is how much a standard deviation is, or at least let me say this is the same amount. I am taking way more values here than I do here. In fact, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I have 19 out of 25 students within 2 values above, 2 percentage points above or below 85. Versus in Class B, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 students in between the 2 values above and below 85. So, way fewer here than here. And in fact, 11 isn't even half of the data. I would need to go out even further to get about half of the data points. So, I hope you're seeing that Class A's standard deviation is smaller than Class B. The standard deviation for class A, we could say it's a relatively smaller value, while class B, I need to go farther out. We need to incorporate, or we need to take on more of the spread to get over half of the data than you would for class A. You can really see this quite visually if you look at how the data is laid out. Notice that it's really tightly packed here around the mean, versus the mean here, it's kind of spread out a little bit more. The tightly packed data represents a smaller standard deviation. You don't got to go out that far to get most of the data, versus a more spread out data set represents a higher standard deviation. You have to go farther out from the mean to encompass most of the data. So we could say here that the standard deviation for A is smaller than the standard deviation for B. These are some things you might have to look for on the SAT. And just really understand, you're not going to have to calculate a standard deviation. You're not going to have to know the formulas and the ways in which to work with it. Really, you just have to understand the concept of this. You have to understand that a standard deviation really means how far away is the data from the mean. Are you really tightly packed together, like you have pretty consistent data results, or are they pretty farther spread out, okay? That's all that we're saying here. If you have any questions about what we're going over, please feel free to contact me. My email is klinford, that's KLINFORD, at wccnet.edu. Let me know what you thought of the video, if you have any questions or comments, and until next time, take care.